Alright, today's lesson is on the characteristics of absolute value, and primarily today we will be focusing on what the graphs look like and the transitions from the parent function. So, quick definition of absolute value. Absolute value is the distance away from 0 on a number line. Important thing to remember about absolute value: anytime we take the absolute value of a number, it can never ever equal a negative number. We want to be careful though that to say that the absolute value is always positive, because that's not true, because the absolute value can be equal to 0 and 0 is not negative or positive. So the standard form of an absolute value function is y equals a multiplied with the absolute value of x minus h plus k at the end. And I'm going to briefly describe what a, h, and k are in relation to the absolute value function. Very similar to that of a function in vertex form of a quadratic. So our a, h, and k are all very similar. Remember, in a quadratic, our vertex was at h comma k. Same thing holds true for absolute value. So our a value is going to tell us one of three things. It's going to tell us whether the graph gets wide, whether it gets narrow, or whether it is flipped. Okay, and we can tell just based off of the given number. Our h value is going to tell us which direction we are going to be moving horizontally. So this will be a horizontal shift. Okay. And then lastly, our k value is going to tell us which way we will be moving in the vertical direction. So this is a vertical shift. Okay. So remember, a is going to be wide, narrow, or flipped. H is going to be a horizontal shift, and k is going to be a vertical shift. Very, very similar to the a, the h, and the k in a quadratic function. So let's take a look at a couple of examples. Okay, so it says in example 1, the parent function is graphed below. Using the calculator, sketch a graph of the new function and describe how the graph of each function is related to the parent function y equals the absolute value of x. Well, I'm going to tell you that we're not going to do it on the graph, but I'm going to show you how to do it by hand. In case your homework you don't have access to a graphing calculator, you can still understand what's going on. So I'm going to start off by picking some numbers such as -1, 0, and 1, and if you need to graph more x values, you can. So when I put -1 in here, -1 absolute value of that, the square is irrelevant, you don't want that there. So -1 would be +1 when we put it into the absolute value, because remember, it can never be negative. But then when I take the opposite of that, I'm going to get -1 for my y value. So -1, -1 is my first point. Now, when I choose 0, the absolute value of 0 is still going to be 0, and the opposite of 0 is 0. So another one of my points is 0, 0. And like the quadratic function, this is going to be symmetric. So 1, -1 is also another point. So as you can see from the parent function, this graph is going to be flipped upside down. So that's what it looks like. So the change in the a value when a is equal to a negative, your graph is going to be flipped upside down. Okay, let's take a look when a is equal to 5. So here I have y equals 5 times the absolute value of x. So again, I'm going to choose those same numbers, -1, 0, and 1 for x, and see what I get for y. So when I put in -1, the absolute value of -1 is +1. 5 times 1 is 5. So -1 all the way up to 5. When I put in 0, absolute value of 0 is 0, times 5 is still 0, so I get out 0, 0, so still at the origin. When I put in 1, absolute value of 1 is 1, 1 times 5 is 5, so 1, 5 is also another point. So as you can see, this graph gets very, very narrow. So when a is greater than 1, our graph is going to get narrow. Very similar to that of what we did with the quadratic function. Okay, so in C, y equals 1/8 times the absolute value of x. We have to be strategic about the numbers that we pick here just because we have a multiplier of 1/8. So the numbers that I'm going to choose here are -4, 0, and 4, and I determine those numbers because I know that I can graph a point when I multiply it by 1/8. So the absolute value of -4 is 4. 4 times 1/8 is going to be a half. So -4 1/2 would be one of my points. When I put in 0, absolute value of 0 is 0. 0 times 1/8 is 0, so another point at the origin. And it is symmetric, kind of like the quadratic function. When I put in 4, absolute value of 4 is 4. 4 times an 8 is 1/2, so 4, 1/2. And as you can see here, when I have a fraction out front that is less than 1 but greater than 0, so 0 is less than a, which is less than 1, aka a fraction, our graph is going to get wide. In problem D, here I have y equals the absolute value of x, and then I have a +4 on the outside. Notice that comes after the absolute value. So what happens here if I choose some numbers again, such as -1, 0, and 1? We're going to get some y values out. -1, the absolute value of that is 1, and 1 plus 4 is 5, so -1, 5. When I put in 0, absolute value of 0 is 0. 0 plus 4 is 4, so 0, 4. When I put in 1, absolute value of 1 is 1. 1 plus 4 is 5. So notice this graph is shifted up 4 units. Okay, so the change in the k value, k because it's on the outside, not h, h is on the inside. When k is positive, we are going to be shifting our graph up however many units. So we can say up k units. So if k is 5, we'd be shifting it up 5 units. If k was 1, we'd be shifting it up 1 unit. When I take a look at E, here I have absolute value of x -3. So again, choose some numbers. -1, 0, and 1. So when I put in -1, absolute value of -1 is 1. 1 minus 3 is -2, so -1, -2. When I put in 0, absolute value of 0 is 0. 0 minus 3 is -3. When I put in 1, absolute value of 1 is 1. 1 minus 3 is -2. So our graph has that same V shape, just shifted down 3 units. So when k is negative, we are going to shift down k units. So if k is -5, we shift down 5 units. Okay, so without making a table this time, since our k value is +1, we're going to shift this graph up 1. Notice if for my parent function I start at 0, 0, my next point is 1, 1, so I went up 1, right 1, so I'm going to go up 1, right 1 for that new function, and up 1, left 1. Same V shape, just shifted up 1 unit. Alright, so in this last set here, notice our values are now on the inside, and if you remember from the quadratic function, we ended up doing, when we had stuff inside of the parentheses in vertex form, we ended up doing the opposite of what we really thought was going to happen. So again, I'm going to show you this by starting off with a table of values. So you got to be careful this go around on what you choose. You want to choose numbers that are around this -3. So some numbers that I might choose would be something like -2, -4, -5, just to kind of give you an idea of what is going on here. Now if we choose numbers and we go to graph it and it doesn't turn out exactly like a V-shaped graph like we think, then we might want to choose some other numbers. So if I put in -2, -2 minus 3 is -5, absolute value of -5 is +5, so -2, 5 would be a point. If I put in -4, -4 minus 3 is -7, absolute value of -7 is +7, not going to be able to graph that point. If I put in -5, -5 minus 3 is -8, absolute value of -8 is 8. So that really doesn't give me an idea of what happens to this graph. Okay, so you can keep choosing other numbers, but remember, when we have a -3 on the inside, we really want to do the opposite of what we think. So instead of going to the left 3, we go to the right 3. So now if I choose a number like 3 and I put it in, 3 minus 3 is 0, absolute value of 0 is 0. So 3, 0 would be a point. Now, between any 2 points, I can draw a straight line. So notice, when I draw in this line here, that looks like this portion of the graph. Okay. So now if I choose a number slightly bigger than 3, such as 4, when I put in 4, 4 minus 1 is 1, absolute value of 1 is 1. So my right side of the graph looks like that. So that graph ended up getting shifted to the right 3 units. So the change in the H value affects the graph by, if I have a -H inside of the absolute value, I'm going to be shifting my graph right H units. So if it was -7, I'd be shifting it right 7 units. Here I have absolute value of x plus 2 inside the brackets. So if I choose my numbers wisely this time, unlike problem D, I'm going to pick numbers that are the opposite here. So numbers like -2, -3, and even -1. So when I put in -2, -2 plus 2 is 0. Absolute value of 0 is 0, so -2, 0 would be a point. When I put in -3, -3 plus 2 is -1. Absolute value of -1 is +1, so -3, 1 would be a point. And put in -1, -1 plus 2 is 1. Absolute value of 1 is 1, so -1, 1. V-shaped graph, shifted to the left 2 units. So when I have a positive H on the inside, I am shifting to the left H units. So when we take a look at F, since it is negative on the inside, remember -H, we are shifting to the right H units, so I'm going to put a point on +1, and then I'm going to make my V-shaped graph from there. Okay. So as a quick refresher, when A is greater than 1, our graph is going to narrow. When A is a fraction between 0 and 1, our graph is going to widen. If A is negative, the graph is going to be flipped upside down. When our H value is negative, we are going to be shifting the graph to the right h units. When our h value is positive, we're going to be shifting the graph left h units. When our k value is positive, we're going to be shifting our graph up k units. And when our k value is negative, we're going to be shifting it down k units. So in this next example, it says, describe the transformation that would result in the graph based on the given function. Then identify the vertex, the domain, the range, and a point on the graph. Okay, so when I look at A, my A is negative, therefore this graph is going to be flipped upside down. Since I have a negative on the inside, remember, negative h value means that we're going to be shifting it to the right 3 units. And a positive 4 on the outside means that we're going to be shifting our graph up 4 units. Okay. Our vertex is going to be, remember, y equals a times the absolute value of x minus h plus k. So it's going to be the opposite of what we have on the inside. So the opposite of negative 3 is positive 3. And the same value on the outside, so 3 comma 4. Domain, just like in our quadratic function, is always going to be all real numbers. Our range, so when we think about the graph, just like in vertex form, our range is going to be based on this. So if we give an idea of what this graph looks like, it's going to be flipped upside down. We're going to be shifted right 3 units and up 4. So right 3, up 4, and it's upside down. So this is what it looks like. So all of our y values are going to be below this point. Well, that y value there is positive 4, so our y values are y less than or equal to 4. Okay. The point, another point on this graph, so it's just telling us to select any other point on this graph. So substitute in a number that is close to this value of 3. So like if I choose 2, 2 minus 3 is negative 1. The absolute value of negative 1 is 1, but then I want to make it negative. So negative 1 plus 4 is positive 3. Again, I'll show you how I did that. Opposite of the absolute value of 2 minus 3 plus 4 on the outside. So this whole thing becomes negative 1 inside of the bracket. And I still have the opposite and plus 4 at the end. Absolute value of negative 1 is 1. We're making that negative. Negative 1 plus 4 is 3. In B, here I have y equals the absolute value of x plus 2 and then minus 3 on the outside. So this plus 2 means that I am going to be shifting it to the left 2 units. The minus 3 on the outside means that I'm going to be shifting it down 3 units. My vertex, opposite of the number on the inside, so that would be negative 2. Same as the number on the outside, which would be negative 3. My domain is all real numbers. Range, again, if you need to, think about the graph and what that looks like. Since A is positive, it is going to be pointing up. So all my y values are going to be greater than or equal to this value here at the end, which is negative 3. Another point on the graph. Okay, so select a number that's opposite here. So like negative 1. So the absolute value of negative 1 plus 2 and then minus 3 at the end. Negative 1 plus 2 is 1. Absolute value of 1 is 1. So 1 minus 3 is equal to negative 2. So another point on this graph would be negative 1, negative 2. In C, here I have y equals negative 2 times the absolute value of x plus 1. and plus 4 on the outside. So based off of the negative, it is going to be flipped. We just pay attention to the number here too, so this graph is definitely going to be narrowed. Plus 1 on the inside means that we are shifting left 1 unit. Plus 4 on the outside means that we are shifting up 4 units. So our vertex is the opposite of the number on the inside, so -1, same as the number at the end, so comma 4. Vertex at -1, 4. Domain, same as all before, all real numbers. Our range, again, if we think about this graph, it is going to be flipped upside down. So our range is going to be less than or equal to our value at the end, which is 4. And now another point on this graph, so a number that is close to +1 or the opposite of that. So like you could choose -1, so -2 times the absolute value of -1 plus 1, and then plus 4 at the end. -1 plus 1 is 0, so the absolute value of 0 multiplied with -2 plus 4. Absolute value of 0 is 0, so -2 times 0 plus 4. -2 times 0 is 0, 0 plus 4 is 4. So another point on this graph would be 0, comma, another point is not 0, it would be -1, comma 4, but we already selected that. So choose 0. When you put in 0, 0 plus 1 is 1, times -2 is -2. -2 plus 4 is +2, so 0, comma 2. At this point, what I'd like you to do is to pause the video. I want you to try the next 3 problems on your own. When you've completed those, unpause the video and check your solutions. Alright, for your solutions on the U-tries, for A, you should have gotten that it widens and it is shifted to the left 7 units. Vertex at -7, comma 0, because there is nothing after the after the brackets, so that would be 0. Domain, all real numbers. Range, y is greater than or equal to 0, because the graph points up. Another point on this graph would be 2, comma 3. For B, this graph is flipped upside down, shifted to the right 5 units because it's negative, shifted up 1 unit because it's positive on the outside. Vertex is at the opposite of -5, so 5, comma 1. Domain is all real numbers. Our range, y is less than or equal to 1 because this graph is flipped upside down. Another point on this graph would be 4, comma 0. For C, we have shifted to the right 4 units because it's negative on the inside. We've shifted up 2 units because it's positive on the outside. Vertex, opposite of -4 is 4, comma 2. Domain is all real numbers. This graph is pointed up, so greater than or equal to, so y is greater than or equal to 2, the number at the end. Another point on this graph would be 3, comma 3. This concludes our lesson on characteristics of absolute value.